I'm David Linden. I'm a professor of neuroscience at Johns Hopkins University School of Medicine. For many years, my laboratory has studied neuroplasticity, that is, how the brain and the nervous system are changed as the result of experience in the world.
Chapter 1: The Connection Between Mind and Body.
So, like a lot of biologists, I've been resistant to the idea that our mental life affects our body profoundly, because for so long it seemed like something that was untestable and ethereal and operated in a different realm from biological science. But my father was a psychiatrist, and he told me, when talking cure psychiatry works, it doesn't work in some magical psychological realm that is divorced from biology. It works because it changes your brain. And the same is true of any behavioral process, whether it is meditative practice or psychotherapy or controlled breathing or what have you. These things aren't working in the ether. They are working through biology, and in just the last 10 years, our understanding of that biology has gotten a whole lot better. So it's not as if that all claims that have been made through history about mind-body medicine will turn out to be true and will turn out to be understandable. But a subset of them that seemed supernatural at one point will turn out ultimately to have real biological explanations. So much of our understanding of both daily functioning and things going wrong in disease right now is focused on the body by itself. There is now a revolution where we're realizing that many disease processes and many things that we do every day, from sleeping and waking to eating food and being hungry, things like cancer, autoimmune disease. These are things that we are now learning are strongly under the control of the brain. And when things are under the control of the brain, it's not just something that happens subconsciously. It means we have the option to control them with our behavioral practices, whether these are breathing practices, meditative practices, psychotherapy, exercise. It opens up an entire new way to think about disease. Maybe this would be a point to talk about interoception and exteroception. So when we think of the senses, we tend to think of smell, taste, vision, touch, hearing, things that are pointed outward towards the world that give you information about the world around you. But we also have inward-pointing senses, so-called interoceptive senses, or senses of self, that tell us things like, is my bladder full? Is my bowel full? How is my head in relation to the force of gravity? These interoceptive senses are crucial to the ongoing conversation between mind and body. If these signals need to be received really fast, then they are conveyed electrically from neurons that run from the body up through the spinal cord and get to the brain. If they are signals that can work more slowly, then the body can secrete a hormone. The hormone passes through the blood system. This is a slower process. Ultimately, it makes its way to the brain and binds receptors on neurons or other cells in the brain to produce a slower effect. Yet another interesting way is that the brain is continuously responding to our breathing rhythm and our heartbeat. So every pulse of the heart has a very slight effect on dilating arteries in our brain, which our brain can then sense and act upon. And that's a very rapid signal. These are the ways that the body talks to the mind, and of course the mind, as instantiated in the brain, will speak back through many other mechanisms, some of them being neural signals, and there are a couple of different kinds of these. Some are the volitional or somatic motor system. So when you have a thought and you say, I want to raise my arm, and you raise your arm, that's something that we all know about, and that's something that is conveyed from the mind to the body in a conscious way. But there are also subconscious ways of signals flowing. And this involves something called the autonomic nervous system. And this is mostly a phenomenon in which the mind controls the body at a level that's below your level of consciousness. The autonomic nervous system is in turn divided into two general branches: the sympathetic nervous system, which people say prepares you to fight or flee, or the parasympathetic nervous system, which prepares you to rest and digest. And so, as you can imagine, the parasympathetic and the sympathetic nervous systems are somewhat in opposition. They're yin and yang, so to speak, of the way the mind controls the body subconsciously. There are other ways too. So the mind can control the body through the release of hormones that are released by the brain. They affect places like the pituitary gland and the adrenal gland, which secrete still more hormones, and these are conveyed through the circulatory system broadly to all sites in the body. So they tend to have broadcasted general effects. So hormones, neural signals, and then the third way is through control of the immune system. And these are through a class of specialized hormones for the immune system, molecules called cytokines.
Chapter 2. Hacking the hunger system with GLP-1.
So we think of eating and hunger as being a very straightforward thing. Oh yeah, I'm feeling a little hungry. I eat something. Now I don't want to eat anymore. But it's really complicated, and it involves a lot of continual dialogue between the body and the mind, using both the senses that are pointed out at the world and the senses that are pointed inward at the body. So if you can imagine walking down the street in New York City, and you're a little hungry, and you smell some pizza. That smells good. And the first thing you're doing is you're making a decision. Am I hungry? Do I want to go seek out where this odor is coming from? Oh, yes, I do. So you're using interoceptive information to say, yes, my stomach is not distended and full of nutrients, and I feel hunger. It's been a while since I last ate, so I'm interested in this idea. You're using your memory to say, oh, yes, I remember that I like pizza. That's a food that I enjoy. And so these smells are bringing up positive associations, and that is influencing your decision to go seek it out. And then let's say you order a slice, and you have it in your hand, and you're looking at it, and you're seeing it, so you're taking in information with your eyes, you're smelling it, and then you're making a decision. Do I want to put this in my mouth or not? And if it smells a little off, if you sniff it and you think it might have spoiled or the oil is rancid or something bad, you're going to say, well, no, maybe I won't put that in my mouth after all. But really, eating is a series of decisions. So now let's say you've taken a bite and you go, oh, that's delicious. Yes, I'm tasting the salt, I'm tasting the fat, I get that nice yeasty thing from the crust. There's also mouthfeel in my mouth. Am I going to swallow this bite? And you're saying, oh, yes, this is palatable food. There's nothing wrong with it. And so I won't spit it out. I'll swallow it. That's yet another decision. And then you're going on eating your slice. Perhaps you're walking down the street and you have to make a decision. Am I getting full? This slice is enormous. So am I going to finish it, or am I going to chuck some of it in the trash and leave it be? And that decision uses several different streams of information coming from your body. It's using fast neural signals from your stomach that are saying, how distended is my stomach? How much has it swollen as a result of food filling it up? And it is also using fast information from the stomach. There are cells in the lining of the stomach that evaluate the nutrient content of the food. This is why you can't just drink a lot of water, for example, distend your stomach, and then suppress your appetite. That doesn't work as a diet strategy. Your stomach knows what's inside. It can tell the difference between water and food, and it can even tell what kind of food is there. Is it fatty? Is it proteinaceous? Is it carbs? That sort of information. Saying, oh yes, there are proteins there are fats there, there's a fairly high level of them. And these are signals that go rapidly to your brain and inform the decision, should I terminate this meal and stop eating, or should I keep going a little while longer? And then, say, 20 minutes later, when you are making a decision, do I want to eat again? There are yet other sensors in not your stomach, but in the first part of your small intestine that are evaluating the nutrient content of the food as it passes there and saying, I just ate. I have plenty of nutrients. I have a feeling of fullness. I'm not going to eat again for a while. How does that happen? Well, that is a slow hormonal signal, and when food is sensed by particular neurons in the lining of the small intestine, they secrete a hormone, and the hormone is called glucagon-like peptide 1, or GLP-1, and this hormone has several effects. It acts on receptors in the stomach to slow gastric motility, so your stomach empties less quickly. But more importantly, it goes to centers in your brain that control your appetite, and they suppress your appetite for tens of minutes or an hour or two afterwards. So we all know that if you put sweet food in your mouth, it tastes sweet, and that the reason for that is that on your tongue and in your oral cavity, there are special sensors for sugars. But what most people don't know is that there are similar sensors for sugars actually in your stomach and in your small intestines. And those sensors send information to your brain to guide decisions like, should I stop eating food right now? Curiously, though, while artificial sweeteners, as are widely used in sodas and other foods, they do a very good job of mimicking real sugar for the sweet sensors that are in your oral cavity. They don't fool the sensors that are in your stomach and your intestines because those sensors are molecularly different. So what that means is when you eat artificial sweeteners, there's a mismatch. Your mouth is telling you, oh, this is sugar, but your gut is saying, no, I don't think so. This isn't real sugar. And as a consequence, your brain is getting conflicting signals, and this is probably some of the reason why artificial sweeteners are really not a very effective strategy for losing weight. If you haven't been living under a rock for the last few years, you've heard that there are very popular diet drugs that are based upon the hormone GLP-1. Now, GLP-1 is a class of molecule called a peptide. It's a short bit of a protein. And these peptides are broken down very quickly in your bloodstream. So when your small intestine secretes GLP-1, that signal is only acting on your brain very briefly. And so you would need to inject many times a day, and it wouldn't be an effective drug. But some clever chemists at the drug company Novo Nordisk realized that you could take the natural GLP-1 molecule and hang chemical groups off the side. In particular, you could hang fatty acids off the side. And these fatty acids cause this GLP-1-like molecule then to bind to a protein in the blood called albumin. And when it's bound to albumin, it's much more resistant to being degraded by enzymes, and it's much more resistant to being immediately excreted by the kidney. As a result, while natural GLP-1 acts for only minutes, this modified GLP-1 that makes a GLP-1-based drug can suppress appetite for a very, very long time. It can live for a long time in the bloodstream, and as a consequence, you can use it to make a drug that you inject once a week and suppresses appetite strongly. I'm talking about things like semaglutide, which is known as Wegovy or Ozempic, or tirzepatide, which is known as Zepbound or Mounjaro. And these drugs, by mimicking this natural signal, are very effective at suppressing appetite, and people are losing typically between 12 and 17% of their body weight after taking a once-a-week injection of these drugs over many weeks. But they seem to be even better than that. In other words, if you compare the health benefits that you can measure from people who are taking GLP-1 drugs, it seems that there are beneficial effects above and beyond what you would predict from just the amount of weight they're losing. And we don't entirely know why this happens, but it makes sense biologically because the receptor for the hormone GLP-1, which is also going to be activated by these drugs, it's not just in your stomach and it's not just in your brain, it's in all kinds of organs. It's in your heart, it's in your kidneys, it's in your liver, it's in all kinds of places, and it's doing something good there. We don't entirely know what that is, but it's probably some sort of anti-inflammatory effect that provides benefit beyond just what the weight loss is doing. GLP-1 based weight loss drugs aren't perfect. They have a lot of benefits, but they have some side effects. Some people feel nauseated. Some people feel gastrointestinal distress. Sometimes people feel brain fog or a loss of energy on them. And the newer generations of weight loss drugs that are being developed right now may help to make those side effects better. The other thing is that when you eat less, you don't just lose fat mass, you also lose muscle mass. So you got to be really careful. If you're losing weight on a GLP-1 drug, you want to go to the gym and do load-bearing exercise to keep your muscle mass up. You want to make sure that you're consuming enough protein to allow your muscles to be able to continue to stay at a reasonable size. So some of these problems may only emerge when we see people using them for years and years and years. And you have to use them for years and years and years because they only work as long as you consume them. You go on a GLP-1 drug, you use it for a year, you go off the drug, you're going to gain all the weight back. It doesn't seem to have a permanent reversal effect. When these drugs were first developed, if you had asked me as a neuroscientist, would these drugs that suppress appetite also suppress the other kinds of rewards that people tend to overdo, like alcohol or drugs of abuse, or even compulsive shopping or gambling, all of which activate the brain's reward circuitry? I would have guessed no. I would have said there's going to be a separate circuit for appetite, and there are reasons to keep that apart from the general reward circuitry. But the indications are that this is not entirely the case. So it's early days, but there are promising indications that the GLP-1 based weight loss drugs have some effectiveness for helping people to control their alcohol consumption and to help them get off of psychoactive drugs, and maybe even to deal with compulsive behaviors that are making problems in their life, like compulsive shopping or compulsive gambling. It's going to be really interesting to see how this plays out in research in the next few years. So there are some really interesting things that have come out in the last few years in body to brain signaling that have implications for weight loss. One of them has to do with exercise. We know that when you exercise intensively, it stimulates appetite. And so some people think, well, I might go to the gym and work out real hard, but then I'm going to be real hungry and then I'm going to eat a lot of food and maybe there won't be a net benefit. It seems to be, though, that intensive exercise does have a net benefit. The amount that it stimulates your appetite doesn't entirely compensate for the amount of weight that you burn through the intensive exercise. Why is that? Well, part of it seems to be that when you have very intensive exercise, you produce a metabolite called lactate. It becomes conjugated in your body with an amino acid called phenylalanine, and this conjugated compound seems to act through a rather complicated biochemical cascade in the body to get to the brain to suppress appetite itself. So intensive exercise really does seem to be a good thing to do. Very few people can lose all the weight they want to lose from intensive exercise itself, but it is very definitely a benefit. And of course, it has myriad benefits well beyond weight loss and looking good. It has benefits for your mood. It has benefits for maintaining your cognitive function as you age. There's all kinds of great reasons to want to exercise intensively, but weight loss is one of them. Since 1960, the average person in the United States is 27 pounds heavier. That's a lot. Why is that? It's not that the genetics of people in the United States has changed. It's not like there's a toxin or there's a change in our metabolism. The reason for this is the people who are making our highly processed foods, as we find both in restaurants and also in the supermarket, have laboratories where they figure out how to manipulate our appetite systems in our bodies and brains in order to get us to overeat. And we have an evolutionary history, right? Through most of our time as humans, there have been intermittent famines. Food has often been scarce. So it has made sense in those situations. If you come across a very highly caloric fatty food or something really sweet, it made sense to snarf it all down and to put on a little weight so that the next time there was a famine, you might survive and make your way through it. There's a mismatch, though. Most people in the world, and certainly people in the United States, don't live in that famine-laden environment anymore. And as a consequence, when food service corporations, through clever engineering, override our natural inclinations to eat and stop eating with specially engineered foods, they are exploiting this ancient circuit in our brains that says, pack on the fat, pack on the sweet, so that you can survive to live another day.
Chapter 3, Voodoo Death, Broken Heart Syndrome, and Placebos.
Every scientist I know has their own favorite papers that they like to keep in a file folder and look at because they're interesting or revolutionary or odd. And for me, one of these is the 1942 report by the eminent American physiologist Walter Cannon about the phenomenon he called voodoo death. Voodoo death, in his telling, means when people believe that they have been cursed and their belief system leads them to believe that they are going to die as a result of this curse or hex being placed upon them, and then they actually do. And you might think to yourself, well, does this really happen? I mean, aren't these just anecdotal reports? I'm skeptical. I don't really believe. But Walter Cannon was not some flake. He was a very, very eminent and careful physiologist, and he documented many cases around the world where people died as a result of being cursed. And he developed a physiological theory to underlie this. He said that the fight or flight part of the autonomic nervous system, the sympathetic nervous system, became hyper-aroused during hex death. And this hyper-arousal set in motion a series of physiological changes that ultimately killed people when they had this set of beliefs. Now, Cannon was acting before we knew a lot of physiology that we know in the modern era. He didn't know about the so-called hypothalamo-pituitary adrenal axis and the production of the stress hormone cortisol that hadn't been invented or discovered yet. And he didn't know about the key role of the parasympathetic nervous system. So Cannon's theory of voodoo death was half right. The sympathetic nervous system is involved, but it actually seems like what you need to have voodoo death is a 1-2 punch. The first punch is the sympathetic nervous system goes into overdrive. The second punch is that the parasympathetic nervous system comes on and stays high in its activation, the rest and digest nervous system, for many, many hours or days afterwards. And these two things together shut down the body and result in voodoo death ultimately. If you don't have the belief that you can be killed by a hex or curse, then it doesn't work. It doesn't work in the spirit world. It only works if you have that belief. And a corollary of that is if a witch doctor tells someone who believes in it that they have cursed them, but then before they die says, no, I've lifted the curse. It's not really happened. I've moved the bones. I've changed the feathers, and this curse is no longer operated, then they can recover. So it entirely is in the mind and the body of the recipient of the curse where this is happening. It's not happening in the supernatural world. It's happening biologically in the mind and the body of the recipient. We might be tempted to think, oh, voodoo death, hex curses, this only happens in societies that have a certain set of supernatural beliefs that aren't the ones that dominate here in the USA or in Western Europe or in East Asia and places that are more technologically advanced. But that's really not the case at all. So there are papers in the medical literature about the effects of fatal misdiagnosis. So, for example, there is a famous case of a man who was diagnosed with liver cancer, and this was a number of years ago in the 1970s when the kind of scans and diagnostics that were available weren't as sophisticated as they are now. And they said, there's not that much we can do with you. We can keep you comfortable. He says, I just want to live through Christmas with my family. And so he got palliative care. He made it through Christmas. Right after New Year's, he dropped dead. So we think, oh, well, the cancer got him. He was able to hang on. That's wonderful. They went in to do the autopsy. They were wrong. He didn't have liver cancer at all. As a matter of fact, he didn't have much wrong with him that was very serious at all. It was his belief that he had a fatal illness that killed him. And it probably killed him in exactly the same way that voodoo death kills people who believe in it. So voodoo death is not just a phenomenon of a certain group of societies around the world. It is essentially also happens in modern medicine with people in white coats, just in a slightly different setting. Everyone's family seems to have a story about a couple where one member died and then the other died of a broken heart soon thereafter. And you think, well, this is anecdotal. People like to tell these stories. It seems romantic. It's something that makes us feel warm and fuzzy about the power of love. But is this really true? If you do epidemiology, if you get a large population and you look at statistics, is it really true that people are more likely to die soon after their long-term partner dies? And the answer is yes. And what people die of are the whole range of things: cardiovascular incidents, cancer, autoimmune diseases. All of the incidence of these things can go up after the loss of a loved one. And it's not just a partner. It can be a close friend. It can be a sibling. In some cases, it can even be a pet. But this kind of emotional state of grieving definitely leads to a worse prognosis for the person who is grieving. That is now well established. There is a fascinating phenomenon that was first discovered by doctors in Japan in elderly grieving people, and it's called takotsubo cardiomyopathy. Tako is Japanese for octopus, and tsubo means trap. And the reason it has this name is because the heart adopts a shape like a Japanese octopus trap. It produces an impairment in cardiac function. Most people recover from this cardiomyopathy, but some people die as a result. And we now believe that takotsubo cardiomyopathy is a consequence of overactivation of the sympathetic nervous system. We have a biological explanation for it that allows us to bridge the behavioral experience of grief to this bodily experience of cardiac impairment. So the belief that one has been hex cursed and then dies, or from an inaccurate diagnosis leading to death, or mourning, its effect on one's health, these are all negative things that can occur as a result of your mental state. But fortunately, it works the other way too. Positive beliefs and positive mental states can work in the opposite direction and can do things like relieve pain or give you better health outcomes. When people think about mind-body medicine, there tends to be a focus on behavioral things. What can meditation do? What can regulated breathing do? What can prayer do? What can psychotherapy or psychosocial support do? And that is an important part of mind-body medicine. But mind-body medicine can also inform the development of drugs or devices, that is to say, more conventional therapies that are based on this understanding. So GLP-1 based drugs come from understanding information that is flowing from the body to the mind. Now we have implanted devices to stimulate the vagus nerve and activate the parasympathetic nervous system that are useful in depression and epilepsy and possibly some other diseases. This is a device that is informed by our understanding of information flowing in the other direction from mind out to body. I think most people have heard of the placebo effect, which is when someone is given a sugar pill or a sham treatment instead of the conventional medical treatment, and they see benefits from it nonetheless. And it can happen in a lot of situations. There are placebo effects for pain, for clearing infections, for improvement in cardiovascular function. To me, what's interesting about placebo effects is that we now have a very good understanding about how many of them work in biological terms. I think pain is probably the best example. When people are given sugar pills or sham treatments and are told this will relieve their pain, and it really does, we now know that this effect can be blocked by the drug naloxone, and naloxone works by blocking receptors for opiates in the brain. And these are not just the receptors for drugs like heroin and fentanyl. They are the receptors for your brain's natural morphine-like molecules, the endorphins and the enkephalin. So the fact that naloxone can block the placebo effect for pain tells us that the placebo effect for pain is being mediated in the body by endorphins and enkephalins, by the brain's natural morphine-like molecules. Placebo effects are best known in the case of pain relief, but they can actually occur for a whole bunch of beneficial medical situations. So you can have a sugar pill or a sham treatment that improves your recovery from surgery and your healing rate, that can modify your immune system, or in some cases, if you are, say, receiving a graft, can help you suppress your immune system. We don't understand all the biology of all the cases where this works, but there are some really interesting experiments that illuminate it. So, for example, if I give you a drug that will reduce your blood pressure, and then I pair that drug with, say, lemon lime flavoring that you drink in a little solution that you take in your mouth, and you pair that a number of times, and then just like Pavlov's dog, now if you drink the lemon lime flavoring, it will be like you had the partial effect of your drug, and your blood pressure will go down, even though the blood pressure medicine isn't being given, only the lemon lime drink is given. It seems as if a portion of the placebo effect is a kind of associative learning, although all the details of that are not yet understood. If you're a drug company and you have a drug that you think relieves pain well, the way that you are required to test it is by comparing it with a placebo. So half the people in the study might get the drug, and the other half of the people might get a sugar pill that they're being told is the drug. For the drug to be approved, it has to work significantly better than the effect that you would see just from the placebo. It's really fascinating to me that it seems like the placebo effect for pain over the last several decades has gotten stronger and stronger. As a result of this, it's harder to show a statistically significant difference for a real drug compared to the placebo, because this placebo is relieving pain to a better and better degree, and showing that something better than that then becomes much more of a challenge. And you might think, well, why is that happening? That's so weird. Why would the placebo effect be getting stronger? It gets weirder. It's not getting stronger everywhere in the world. It's only getting stronger in the United States. Why is that the case? Well, we don't really know, but the best guess is that the United States is one of only 2 countries in the world, the other being New Zealand, where direct-to-consumer advertising of drugs is allowed. And so it may be that somehow this belief in the efficacy of drugs is stronger among people in the USA, and maybe New Zealand, although we don't know it, than it is in other places, and that this is the basis for the enhancement of the placebo effect for pain. So the placebo effect is really counterintuitive. You might imagine that nowadays people know that placebos are used in clinical trials, and when someone is going into one of these trials, they could be thinking, am I getting the real drug? Am I getting a placebo? And you might expect that that would make the placebo effect weaker. But curiously, it doesn't. And it even gets weirder than that. There's a phenomenon called open-label placebo. And an open-label placebo, it seems like it would never work. Open-label placebo is when you say, I'm giving you a sugar pill, and it's just a sugar pill, and that's what we're doing here. And even with that knowledge, which you then think, well, there's going to be no effect whatsoever, you still get a placebo effect. To me, that's deeply counterintuitive, and yet it's been shown over and over again in the literature. And there are trials and whole branches of medicine using so-called open-label placebos. And to me, it's remarkable, and understanding the biology of that is something that is going to be really fascinating. When you look at the power of placebo effects, it certainly motivates you to try to understand mind-to-body signaling to a greater degree biologically. You think, well, where might this lead us to a future medicine? Well, one way is to say, all right, well, maybe there are things we can do behaviorally to benefit in certain situations. If you're recovering from a heart attack, or you've just had this or that therapy, or recovering from cancer treatment, you want to engage in these particular behavioral interventions. But it's not just the behavioral interventions. In other words, understanding this signaling will also open us up for new drugs that manipulate those pathways, or devices that manipulate those pathways. So, for example, we know that psychosocial support gives you benefit in terms of your recovery after a heart attack, or after in terms of your prognosis for cancer. And so one way is to say, all right, well, what are the behaviors you can do? But another way might be to say, well, maybe we could stimulate your brain artificially with a device in a way that would help you heal. Right now, our ability to stimulate the nervous system non-invasively, that is to say from outside the skull, is really, really crude. So there are techniques. There's one called transcranial magnetic stimulation. There's another one called transcranial direct current stimulation. These stimulate large volumes of brain tissue, like the volume of a golf ball, and within they stimulate every kind of neuron in that volume. So they're really crude ways to activate or inhibit very large parts of the brain. But with time, we'll have much more subtle ways of activating small bits of the brain. And not just a small volume of the brain, but even there are parts of the brain where there are different flavors of neurons that that do different tasks that are physically intermingled, and it's been impossible either with an electrode or with one of these outside the skull methods to activate them or inhibit them. But there are going to be genetic optical tricks that we can now do in experimental animals to just activate one particular type of neuron in the brain that ultimately we'll be able to do as therapies for people. And this kind of manipulation that's coming down the pipe will eventually be used to exploit mind-to-body signaling in ways that are medically beneficial. And so mind-body medicine just doesn't help us in the realm of behavioral interventions. It also helps us in the more conventional realm of drugs and devices.
Chapter 4. How Our Brains Fight Cancer.
So nearly 5 years ago, I was given 6 to 18 months to live as a consequence of my diagnosis of synovial sarcoma, an aggressive form of cancer. I underwent surgery because they found a huge mass that was growing in my heart wall, and the mass was enormous. It was about the volume of a Coca-Cola can. I had a very long and elaborate surgery. Before the surgery, they thought this mass was likely to be a teratoma, which is a group of cells that have been present in your body since fetal life that grow in a weird way. So not a tumor, not cancer, a developmental abnormality. But unfortunately, they did the big surgery. They couldn't remove all of the mass. They had to leave some of it that had grown into my heart wall and remains there to this day, a bit about the size of a walnut. And when they did that pathology, they said, well, no, actually, you have cancer, and you have a rare form of cancer called synovial sarcoma, and you're probably going to die within 6 to 18 months. It's a weird thing to be a biomedical researcher and to also be battling a terminal illness. The way I have approached my terminal illness is what I call the way of the nerd. And the way of the nerd is to understand as much as you possibly can about your illness and to feel a sense of agency and control. And for me, that has not been so much about learning all the molecular details about cancer. I'm not a cancer biologist, and I never have been, and I never will be. But because my background is in neuroscience, it has brought me to understand the interactions between mental function, brain function, and my particular cancer situation. For some people, it's the last thing they want to do. The last thing they want to do is to dive into all the biological details and understand the ins and outs of the disease. And I completely respect that and feel like that is a valid choice. But for a subset of us, like me, the way of the nerd is empowering and is a way to deal with a terminal illness and make it possible to thrive in this liminal time while I'm still around. So cancer is an opportunistic bastard, right? Cancer is just cell growth that gets out of control. There are many situations where we need our cells to divide and create more cells, and for that process to stop. We need it when we grow as babies. We need it when we grow up. We need it to regenerate certain tissues, like in our skin that continually grow, or the lining of our respiratory or our digestive system. These are things that are continually renewed. So we need cells to divide. That's a fundamental thing. But when it gets out of control, that's cancer. But that's not just how cancer works. In other words, cancer isn't just a bunch of cells that start dividing and then that's all that happens. When I say that cancer is a bastard, what I mean is that cancer co-opts other systems in the body to prevent the tumor cells from being degraded by your own immune system. It sends out signals that interfere with the immune system and the cells of the immune system to make it think like, oh, there isn't really any problem. No, that was just a hoax. You don't actually need to attack me. And it also co-opts signals that cause the cancer to grow and spread. So we know that many tumors, for example, send out chemical signals that attract blood vessels to grow in and nourish and feed the tumor and promote its growth. That's been known for quite a number of decades. What is really becoming more understood just in the last 10 or 15 years is that the same thing happens with nerves. So there's a dialogue between tumor cells and nerves, actually several forms of dialogue. Many tumors secrete signals that cause nerves to grow into the tumor. They secrete molecules called neurotrophins that cause the nerve cells to grow in the direction of the tumor and ultimately actually penetrate the tumor. And these neurotrophins include molecules called nerve growth factor, or NGF, and brain-derived neurotrophic factor, or BDNF. But it's not just that the tumor talks to the nerves talk to the tumors in many different ways. And one particular class of neuron, which are pain-conveying sensory neurons, secrete a signaling molecule called calcitonin gene-related peptide, or CGRP. CGRP affects immune cells that patrol around the edge of the tumor and sort of nibble at its edges and kill the cells on the edge of the tumor, and as a result, prevent it from growing and spreading. So when CGRP affects these immune cells, which are called CD8 positive T lymphocytes, it suppresses their activity so they don't nibble the edges of the tumor as much, so then the tumor can grow more. And so tumors, when they are innervated, your prognosis becomes worse. And if we can prevent tumors from becoming innervated, this is a whole new promising realm in cancer therapy to slow the growth and spread of tumors. If you buy a doctor a drink or two and you get them to talk to you, they're very likely to say it's not just the conventional medical therapy that determines the likelihood of someone's successful outcome when they're in the hospital or they're being treated in the office. It has to also do with their own mental state and their own psychosocial support. It's well known in cardiology that people recover better from heart attacks and from the treatment following heart attack if they have social support, if they have their family around them, if they have psychotherapy. And this is an observation that has been borne out in a number of studies, but the underlying biology has not been clear. Now we have some very interesting experiments in mice, which are in early days, but are starting to draw out the biological pathways that might underlie that beneficial effect. And this comes from the laboratory of Asa Rolls in Israel. And she has shown that if you artificially block the arteries of laboratory mice to give them heart attacks, that they can recover better if you artificially activate the brain's natural reward and expectation circuitry. This is the dopamine-using circuitry that involves a brain region called the ventral tegmental area. And if you use optical and genetic tricks to activate that circuitry, that the mice recover from their artificial experimentally induced heart attack much, much faster. Their ability of their heart to forcefully contract and pump blood through the body comes back faster than it would otherwise, mimicking what we know about social connection and social support in humans recovering from heart attack. We can do things in laboratory mice that wouldn't be ethical to do in humans, like go in and make manipulations and measurements. And so we can now understand a cascade that goes through immune signaling involves a bypass through the liver that ultimately gets us to the heart and its recovery of function. So it would be obviously comforting to think that social support, psychotherapy, the love of one's family and friends, and social connectedness can help you have a better cancer outcome, can increase your lifespan, reduce the spread, the metastasis of cancer, the growth of tumors. But is this just something we like to think, or is it real? And at this point, there is enough epidemiological evidence suggesting that psychosocial support, either in the case of psychotherapy or more informally through one's social connections, it's not a miracle. It can't replace chemotherapy or surgery or radiation, but it does seem to have some beneficial effect on cancer progression. What does this mean in terms about how we should think about making cancer therapy better? Well, obviously, there are behavioral things that you can do to make your cancer better. Meditative practice, things that reduce stress, seem to be good, and we seem to understand the biology of that because we know that stress hormone signaling promotes the growth and spread of tumors. We know that psychotherapy reduces stress hormone signaling as well. But it's not just behavioral manipulations. Understanding that information is flowing from the brain to the cancer microenvironment, whether it's having an effect on cancer cells directly or on the immune cells that are patrolling around and keeping the cancer in check, this allows us to develop new drug therapies as well. So, for example, there are certain types of cancer that have a neurotransmitter receptor on them called the beta-adrenergic receptor. This is the receptor for a neurotransmitter/hormone called noradrenaline, which confusingly also has the name norepinephrine. It's the same molecule. And people may have heard of drugs called beta blockers, which are drugs that people take to calm their heart rate and feel more calm if they're feeling anxiety. These same beta blocking drugs for a subset of cancers seem to slow cancer progression because the beta receptors on the tumor cells contribute to cancer progression. So this understanding of brain-to-body signaling in cancer allows us not just to have better behavioral measures to combat cancer, but to have better drug use as well. There are a lot of correlational studies that have shown that when people exercise, their cancer outcomes are better. They live longer, they progress less quickly, they're more likely to go into remission. But you got to be suspicious of these studies because the devil's in the details. Well, you could say, well, maybe the people who are more inclined to exercise, maybe their cancer wasn't as bad to start with. Maybe they didn't feel as ill, and that's why they're more likely to exercise. And so it's not really that exercise makes it better, it's a complication of that. Or you might say, well, maybe the kind of people who are motivated to exercise a lot are also the kind of people who are more likely not to have bad habits like smoking or drug use. They're more likely to eat a healthy diet, and it's the reducing drug use and the healthy diet that's beneficial for cancer, and the exercise isn't even it. But recently, there have been a few randomized control studies where we take a group of people and we say, of cancer patients, and we say, all right, you guys exercise, and you guys just do whatever you want to do. We're giving you this pamphlet, but we're not going to enroll you in exercise class. We're not going to monitor you. We're not going to give you social support. And there was just a study published this year in 2025 out of Australia for colon cancer, and the result was remarkably strong. The people who were randomly placed in the exercise group had a 30% improvement in mortality over 8 years. If this were a drug effect, it would be, everybody would want this drug. This would be a massive anti-cancer effect. This kind of study doesn't suffer from the same problems of these post hoc association studies of, is it really the exercise that gave the benefit or the things that go along with the exercise, something merely correlated with it? So the evidence is really looking like the benefits of exercise for cancer are clear, and they're not small effects, they're big effects. If you're battling cancer and you can bring yourself to do it, exercise is one of the very, very best things that you can do. We're recording this in 2025. I was given 6 to 18 months to live in 2021, and so you can do the math in your head and realize that I didn't, fortunately, really die in 6 to 18 months. And yet here I am still alive, and people ask me, why do you think you're still alive? And I said, well, I don't entirely know, but I think a portion of it comes from the deep love that I feel from my wife, Dina. And when I say this, people get a look on their face like, oh, isn't that sweet? He's complimenting his wife. He's taking off his scientist hat, and he's putting on his good spouse hat. And that's not the case. That's not what I mean. When I say that the deep and unconditional love that I feel for my wife is helping to keep my cancer at bay, I am saying that as a biomedical researcher, and I am saying that with the idea that this isn't occurring in the realm of ether and spirituality, that it is occurring in the realm of biology. So how might this happen? How do we get from my wife's deep and unconditional love to my cancer being suppressed? Well, the answer is we don't entirely know, but there's a couple of likely ways. One of them is that it's extremely likely that, like many tumors, my tumor receives nerve fibers from both the parasympathetic and the sympathetic nervous system, as well as sensory nerve fibers. And as a consequence, patterns of activity in my brain evoked by my wife's love, like activation of the ventral tegmental reward and anticipation circuitry, through their action in the hypothalamus and some other brain areas, are conveying signals, electrical signals to my tumor that ultimately suppress its growth and spread. However, it is also very likely that this very same pathway, the activation of the reward anticipation circuitry in the brain, is producing modification of the brain's control of the immune system, and is boosting my immune system through the secretion of immune signaling molecules called cytokines in a way that allows circulating T cells and natural killer cells in my immune system to more effectively attack the surface of the tumor that's large in my heart wall. What's exciting about this, even though it's early days, and even though we don't absolutely know that either of those two biological pathways are indeed the way that my cancer is being kept at bay, what's exciting is that we are now at a point where we have biological hypotheses for what before would have been solely behavioral or spiritual explanations.
Chapter 5. How a Neuroscientist Prepares for Death.
When I got the diagnosis, I was supremely angry. At age 59, I did not feel ready to die. I felt like I have a lot to do. I have people who depend upon me. I have a wonderful wife, terrific children. I don't want to leave them. And I was white hot, angry with the universe. But at the very same time, I felt a very deep sense of gratitude. I've been fortunate in life. I've had a wonderful life. I have terrific people around me. I've been able to have a job that has allowed me to not have a boss and to follow my own curiosity and to use my mind in ways that most people don't get. And so what was remarkable as a neuroscientist is that we tend to think of mental states as being unitary. Are you preparing to fight, or are you going to rest? But it's possible to occupy two very divergent mental states at the same time. So I could simultaneously be exceedingly angry and exceedingly grateful. And that was something that I didn't realize before my cancer taught me that. Another thing is that it really reinforced to me that our brains and our minds are not built to give us the truth, to give us the lowdown about anything. We're not built to know the absolute values of things. Everything is subjective. Everything that we perceive is subject to our emotional state and to our expectations. When I was diagnosed, I thought, well, if I could get 5 more years of life, that would be so wonderful. I could spend time with my family, I could travel, I could do some work in my laboratory, I could have my trainees finish their experiments naturally and not have their careers messed with. So many good things would happen. Getting 5 more years would be great when I was looking at a diagnosis of 6 to 18 months. But if someone had just come up to me before cancer and said, well, you're going to die in 5 years, I would have said, what do you mean? I'm only 59. I should get more than 5 years. What the hell are you talking about? So something as fundamental as 5 more years of life that we think of having a very basic value doesn't. In one context, it seems like an impossible gift. In another context, it seems like being cosmically cheated. But I think the realization that I had that was the most profound for me as a neuroscientist grappling with a terminal diagnosis was the fact that as much as I tried, I really could not, and still to this day cannot engage with the idea of my own death, of a world where I'm no longer in it. No, I can do practical things. I can make sure my will is in order. I can dot the I's and cross the T's, but that's not what I'm talking about. I'm talking about truly cognitively and emotionally engaging and thinking about a world with me no longer in it. I realized that my mind was really kind of skittering across the surface of this idea, that I was not able to engage with it deeply in the manner that I think it really deserved. This probably wasn't just my own personal failing. It was revealing something fundamental about what it's like to have a human mind. I've been in neuroscience for a long time, over 40 years now, and there has been a fundamental change in how we think about the brain. We used to think that the brain was fundamentally reactive, that we waited for information to come in from our senses, and then we would do some processing on it and then react to it. And what we now know is that when we are spacing out, when our brain is idling, when we are not engaging with the outside world, that the brain is not just spacing out, that we are actively trying to predict the future. The brain is a prediction machine, and specifically, it's not just trying to predict the future, it's trying to predict the near future. It's trying to predict the next few minutes, the next few hours, maybe the next few days. Is that rock flying through the air going to hit me in the head? Is this person walking towards me a friend or a foe? Am I likely to become hungry in the next few hours, and how I should plan my day? These are all predictions that are happening in my brain while it idles, while it's in its so-called default mode. Now, the fact that the brain is constantly trying to predict the future presupposes that there will be a future. It presupposes that you're not dead and gone. And so I think this fundamental computation, this fundamental future predicting computation is not just what keeps me and perhaps others in my situation from truly engaging with our own mortality and imagining a world without us in it, but I would speculate that this is what has allowed for afterlife stories being so important in almost, not all, but almost all of the world's religions. Almost all of the world's religions have the story of an afterlife or reincarnation or melding of the divine or some kind of construct in which one's consciousness endures after we die. I think that this is, in some ways, a bug. It is a bug. It's a side effect of the near future predicting circuitry in our brain that allows us to imagine that consciousness goes on after death. Now, I'm not a person of faith. I think that when you die, your consciousness doesn't go on. But I am very sympathetic to these cross-cultural, religious, and spiritual ideas that consciousness endures. And I think ultimately there is a neurological and a biological explanation for why those stories are present all around the world. Some people say, well, do you appreciate the little things more? Like, do you appreciate, the color in the sunset and the taste of your tea in the morning? And, to a certain extent, I guess I do. But really, I am appreciative in the time I have left of the very largest things that life has afforded me. My terrific wife, who I love deeply, my wonderful children, and the good friends and colleagues that I have that have been so supportive. This is what I'm thankful for. This is what I try to remember every day in the time I have left. The wonder and the privilege of being a sentient being on this planet and be able to have a mind and to be curious and to move through the world in this way, it's a miracle. And I find myself ever grateful.
Want to support the channel? Join the Big Think members community where you get access to videos early, ad-free.